A variety of non-quadratic equations can be written in the form of a quadratic equation by using various methods in order to be solved. Let's take a look at some examples. In example 1, we have 1 over x plus 1 over x minus 1 equals 7 over 12. The best way to solve this equation is to eliminate the fractions. To do this, we need to multiply the entire equation by the least common denominator, or LCD. In this case, the least common denominator is 12x times the binomial x minus 1. We multiply each term in the equation by this LCD. Note that in doing this, you should be able to cancel or simplify. For example, when we multiply 1 over x by 12x times x minus 1, the x's will cancel out. When we multiply 12x times x minus 1 to 1 over x minus 1, the binomials cancel out. When we multiply 12x times x minus 1 to 7 over 12, the 12's cancel. This gives us the equation 12 times x minus 1 plus 12x equals 7x times x minus 1. Next, we remove the parentheses on both sides of the equation by using the distributive property to multiply and then combine like terms. Notice that the largest exponent in the equation is 2. This means that this equation is quadratic. To solve a quadratic equation, it must be in standard form. That is, the equation should equal 0. So we subtract 24x and add 12 to both sides of the equation. This will give us the equation 7x squared minus 31x plus 12 equals 0. Next, we factor and get the binomials 7x minus 3 times the binomial x minus 4 equals 0. Setting each factor equal to 0 and solving for x gives us two solutions, 3 over 7 and 4. Be sure to check your solutions to make sure they check in the original equation. In this case, both solutions check. In example 2, we are given x equals the square root of 6x minus 8. Here we need to eliminate the radical bar. To do this, we will square both sides of the equation. Doing this will give us x squared equals 6x minus 8. Again, this is a quadratic equation, so we need to put it in standard form by subtracting 6x and adding 8 to both sides of the equation. This will give us x squared minus 6x plus 8 equals 0. Again, we factor and obtain the factors x minus 4 and x minus 2, which we set each equal to 0. Solving for x in both cases will give us two solutions, 2 and 4. Again, be sure to check your solutions to make sure they check in the original equation. In this case, both solutions check. We can also use the substitution method to solve equations that can be written in quadratic form. This method involves 5 steps. Step 1 is to define a temporary variable u based on the relationship between the variable expressions in the given equation. Substitute u in the original equation and rewrite the equation in the form au squared plus bu plus c equals 0. Step 2 is to solve the quadratic equation obtained from step 1 by factoring or the quadratic formula. Step 3, replace u with the expression defined in step 1. Step 4 is to solve the resulting equations for the original variable. Step 5 is to check all proposed solutions by substituting them in the original equation. This is important because in some cases, one or more proposed solutions will be extraneous and will need to be rejected. Let's look at some examples to see how the method works. In example 3, we have x raised to the 4th power minus 13x squared plus 36 equals 0. We can rewrite x to the 4th power as x squared raised to the 2nd power. To do step 1, we let u equal x squared and replace the x squareds in the equation with u. Doing so will give us u squared minus 13u plus 36 equals 0. Step 2 is to factor the equation to obtain u minus 4 times u minus 9 equals 0. We now take each factor and solve for u. This will give us u equals 4 and u equals 9. However, we are not done yet because we now need to do step 3, which is to replace u with the original variable x squared. Next, we solve the equations for x. This will give us plus 2, minus 2, plus 3, and negative 3. Step 5 is to substitute your solutions into the original equation to see if they check. In this case, all solutions check. In example 4, we are given 2 times the binomial 4x minus 3 raised to the second power plus 7 times the binomial 4x minus 3 plus 5 equals 0. Again, we do a substitution by letting u equal the binomial 4x minus 3. This will give us the equation 2u squared plus 7u plus 5 equals 0. Next, we factor to obtain the binomial 2u plus 5 times the binomial u plus 1 equals 0. We next set each binomial equal to 0 and solve for u. Solving the first binomial for u gives us negative 5 over 2. Solving the second binomial for u gives us negative 1. Now we are ready to replace u with the original variable expression 4x minus 3. Solving the first equation for x gives us 1 over 8. Solving the second equation for x gives us 1/2. Again, you want to do step 5 and check your solutions. In this case, both solutions check. You should look over the examples on the web page and then test your knowledge using Test Yourself.